first to read the note. Okay, so the first one is p-order. P-order is from top to the left subtree and then right subtree. So the principle is very simple. The principle, very simple. Let's look at it. How do we apply this principle and do it? First of all, this one is the root, right? So this is a tree, this is the root. The first one we read should be the root. So we'll read A. And then left subtree. What's left subtree? So many of them. Then this one, the triangle, right? Then the triangle will be a tree. You look at the triangle. So this is the key point. You look at the triangle, it's a tree. So you have to apply the p-order to do that. So which one is the root? B is the root, right? In this subtree. Forget about others. Now your focus is on this left subtree. In this left subtree, B is the root. So you read the root. And then left subtree is D. And then the right subtree is E. So the sequence will be B and then D and then E. Is it okay? So lastly, we look at the right subtree. The right subtree is like that. You read the root, which is C. And then you read the left subtree, which is empty. No, then void. Then you go to read the right subtree, which is F. So if you understand the principle of that, then these are the answer. First, you read the A, then you read the left subtree. So B, D, E will be the second batch you read. Then you go to the right subtree, then C and F will be the last batch. So when I write it down, I give you some spacing right here. It's not because it's like that, yeah. It's how to read it. Do you see that? Okay or not? Okay. Yes. Now we go to the next one. In order. In order, the principle is like that. You read the left subtree and then the root and then the right subtree. So you look at it. This is the left subtree, right? This is the root. The left subtree is here. So now your focus will be on this triangle. How do you read it? Left subtree. So you don't read this one. You go to the left subtree, which is D. And then you read the root of this subtree, which is B. And then you go to E. So the sequence will be D, B, and E. So now you finish the left subtree. You go to visit A, right? The root. So the next one will be A. Lastly, you go to here. Go to here, you see that this is a subtree. So the first one you read should be the left subtree. But left subtree is void. Yeah. So no left subtree. So you don't need to read it. Go to read the root. The root is C. And then the right subtree is F, right? So in this way, so you see this one should be the answer. D, B, E should be from your left subtree, the first step. Then the second step is to read the root, which is A, right? And then lastly, the right subtree, C and F. So it's okay? I write it in this particular manner to help you to know how I read the note in details, right? I can write it very nicely, yeah. But you see that I write it in this way, yeah, is to make it obvious for you. Okay or not? How about the online student? Any comments on that? Comments? Okay. Lastly, p-order, in order, post order. Post order, how to do it? Post order is the principle is to read the left subtree. So we will read the triangle first. And then the right subtree will be C and F, this group, right? And lastly, you exit from A, the root. So once you apply this principle, then it's quite straightforward. Okay, so now you go to apply the principle in this particular left subtree here. So what you do? You take care of the left subtree here. You have only one node, D, and then right subtree is E, and then B. Then you finish the left subtree. Okay or not? So now you take care of the right subtree. So it should be left subtree, which is void for this group here. And then the right subtree, F. The root should be C. Once you finish the left subtree, you exit from the root A. So in this case here, you'll see that we'll do it like this. First, you read the left subtree and apply the principle. Should be D, E, and B. Next, go to the right-hand side, the right subtree. Then you do it is F and C. So you see that Y, F, and C. Left subtree, void, so nothing there. You go to the right subtree, which is F. Lastly, you exit from the root. So in this right subtree here, C is the root. Okay, so you have to be flexible, right? So once you finish the left subtree, right subtree, lastly you go to read the root, which is A. So okay or not? So it should be quite simple, right? How to do it? Any questions here? So you have to know what's the principle behind it. So you apply to that. So every time you look at the left subtree or right subtree, you apply the principle there. Don't look at other parts of the tree. Okay? Then will be very clear. You will not miss anything. Okay? Done. Online students, any questions? Okay. So this one is supposed to be quite straightforward. So this one is linked to the printer. How do you print your jobs? Yeah, so you can put it like that. Then you will print out everything. You don't miss it or other related to the trees. Okay, so this one here, how do we for the binary search tree BST below, trace the execution of the algo insert BST insert recurrence. Yeah, here recursive algo step by step, right? Now, before you know how to do it, you have to understand this one in detail. First of all, so you have a temp data. You compare the one we want to insert is the temp. So your temp is a node, root is a node. You cannot compare them directly. You have to compare the data field, the data part of that. Data part normally is the number, right? So you know which one is bigger, which one is smaller. Okay, so you compare them. If this one is smaller than the root, the data part is smaller than the data of the root, then, sorry, if root left is, then you look at the left-hand side of that, the root's left-hand side, see whether this one, so you first compare with this one. If the data part is smaller than 15, say like that, then you go to the left-hand side. So what you do? You go to the left-hand side. If the left-hand side is empty, nothing there, wow, that's good. Then your attempt will be placed there. But if it's like that, what should you do? Then you don't do anything. You pass to them. Yeah, this one is the attempt. Take care. Right? So it will pass to this group here. So you look at it. If the left is empty, nothing there, then you paste it there. Paste the 10 there. But it's not empty. You have just like this case here. So what you do? You should call this one again. Call this one again to treat this one as a new tree and pass this 10 to this new tree. Full stop. Okay or not? Yeah, so it's very clear. Okay, so the other side will be the same. If it's greater, yeah. So any question? Yeah, so very noisy, yeah. Any questions there? Let me clear that. Otherwise, I cannot continue. Sorry. Very fast. Today, 1 hour we finish. You can go home or go to the canteen. Very fast. If you want to leave earlier, you have something going on, you can do that. Yeah, no problem. Okay. So the idea is to compare with 15. If the number you have is greater than 15, what you do? You walk to the right-hand side, and this one is a tree. Is the right sub-tree. Then you check whether someone is there. If nothing there is void, then you paste your 10 there, right? So your 10 will be placed there because it's empty, right? But if there's a tree there, you do the same thing. You pass this value, this 10, the note, to the right-hand side and treat this one as a new tree. It's a new tree, so you see that you treat this one root dot right as a new tree. Forget about others. And then the one you want to attach there is 10. So it's a recursive algorithm. So once you understand this one, so now we would like to put the 10 called 16 there. Okay, so it's actually very simple, right? So you compare with 15. You compare with 15. Which part you go? Left hand side or right hand side? Greater than 15, right? So should go to right hand side. So now we go to the right hand side. The right hand side now is a tree here. This is our new focus. Forget about other parts of that. So we'll go to the right subtree and then pass everything to this right subtree, the 10. So now we create another process. It's just like here, you look at it, oh yeah, so we pass it to you. Then I go. Then this one will be worried about that one where we will create a new process. So now the root is 18, right? The root is 18. So the next step is the 16 will be compared to 18. So which side you go? Left-hand side, right? Left-hand side. So the next one is like that. This is a new tree, and we'll go to the left-hand side. Go to the left-hand side is not void. It's not void, right? So we have to treat this one as a new tree. 15, 17 is a new tree. Now is our focus. So we compare, so we pass this 16 to this particular tree. It's our new tree, right? And then let this tree handle it. Okay, okay or not? Yeah, so you know that what's recursive. So although at the very beginning, the tree is more complicated, but once you go to left-hand side or right-hand side, left subtree, right subtree, it becomes simpler and simpler. You will go to the destination in a few steps. Okay, so now the tree is this one, the left subtree. So 16 is supposed to attach to it. So we go to, you compare with 15 here. So you go to the right hand side or the left hand side. It's greater than 15, you go to right hand side. So on the next page here, you see that this new tree here has only two nodes, 15 and 17. You compare to that first, and then you go to the right hand side, right? Because greater than 15. So at this point in time, you have only one node, but this is a tree. It's a one node tree, right? So we will create the process again. We create the process again and pass this one to this new tree, this new one node tree here. So the next one 16 will compare with 17. Once you compare with 17, you go to the left hand side or right hand side, smaller than that, left hand side. We'll go to left hand side, right? Once the left hand side is void, nothing there. So according to our algo, you put it there. So eventually, so 17 is a single node tree here, and the left hand side is void. So our 10 will be attached to that, right? Then we finish it. Yeah. So although we know how to do it, visualize it, well, we know how to do it. But actually the principle can be applied to every step, and then we are very sure that this is correct. So eventually this is the answer. You will attach to the node 17. So like that, you compare with this one, you go to the left hand side, and you can see that this one is void. Now here. So you put it there. So you have to go through it. Although it's very simple, you know the answer. You have to make sure that you pass through every step of that. You know what it is. And this is recursive, right? So your tree has 10 level, 5 level, 100 level, it doesn't matter. Computer will do it and find a place to put it there. Any questions here? Any questions? Yeah. If not, then the online, yes.
What if they give you the same number, like for the 15, right, there's 2 15s. So how will you know if for normal tree, should we go left or should we go right?
According to the algo, is left sub 3 is less than or equal to.
This one go to the right side.
Which one?
The 15. The bottom one. The 18 connected to 15.
No, it's greater than 15, right? 16 is greater than 15. You go to this side.
It's the same number, like if they give another 15, like in this case, normally.
Then you go to left hand side.
In this case, it's went to the right side, right? For normal tree, like in general, should it go to left or right, or it doesn't matter?
No, according to the algo, this one is here. This one is here. Less than or equal to. So to go to left hand side.
But in general, if they never give code, should we like if they ask us?
It's understood like that.
No,
this one is well defined.
If they never give the code, like in another question, like maybe they never give the code, then
I will tell you that all the numbers are distinct. Yeah. You look at the exact question. Yeah. I always exclude this one. Yeah. So don't give you any trouble. But if you want to go to the detail, then you look at it, whether it's equal or not. This one is less than or equal, then this one is greater than. It should be like that. So you read the one here. So a small point, yeah, sometimes will affect the place you attach that. Okay, I don't see any comment from the online students. Seems that they know what it is. Next one. Next one is to check whether you're smart or not, right? the following algo is used to compute the number of leaves in a binary tree. Number of leaves. So what does it mean by a leaf? Leaf is very simple. You look at it, this is a tree, right? The leaf is something like that, no children. Note number 3 is a leaf. This one is a leaf. 19, a leaf. 17 is a leaf? No. It has a child, right? So the last one, 15 is a leaf. Yeah, so it's like that. So if we are given a tree like that, we want to know how many leaves are there. How many leaves? Okay. So this is the algo we want you to check. If it works, then you prove it. This is correct. How to prove it? So you find a way. So maybe normally is the mathematical induction, all this to make it very complete. If not, then make a correction. So now whenever you have a tree, you have to check systematically. You must have a procedure how to do it. Right? What's the procedure? The procedure is here. You have checked whether it handled empty tree. Empty tree means you have no tree, or you have one node tree. You have only one node. The last one is a general tree. General tree, you know that you have children, you have child, that one is called. You have to check it one by one. You look at it. So if the tree is empty, now return 0. So take care of the empty tree, right? This one will take care of the empty tree. Okay, so else then you will be the left subtree plus the right subtree. How many leaves there? Right? So you are taking care of the left and right. So it's a general tree. You miss one point, one node tree. Can we say that? If there's a one node tree, what should you do? You go through it, then the answer is not correct, yeah, because the left and right all 0, all right? So because for the tree, one node tree, how many leaves? Only one leaf, the root is the leaf, right? It has no children, so it's 1. Okay, so in short, when you deal with the trees, when you want to check systematically, you have to look at these 3 cases. Okay, let's see. So we missed something, so we have to correct it. So what should you do? So we missed the second point, one node tree. How can we tell if this tree is equal to one node tree? What's one node tree? How can you define it? One node tree means that your right subtree and left subtree, they are empty, right? If your right subtree is void, the left subtree is void, that means you have only you yourself. It's a one node tree. So with this in mind, we can modify this one to add one more case here, which is one node tree. And how do we describe the one node tree? You have to use the children, the left child and the right child. Okay, so we take care of the empty tree, and also we take care of the general tree. We miss one point. This guy is not there, so we have to fix it. Okay or not? Okay. Now, once we fix it, this is the one here. So we add one more case there. Else if. So how do we describe the one node tree? We say that, oh yeah, if this one, the left subtree is void, the right subtree is also void, then you return 1. If it's one oak tree, how many leaves? One guy or one leaf, right? So now you take care of all the three cases. It should be complete. Should be complete. You try it. You try it. Yeah, it works. It works. So we learn from this example that when you do the systematic checking for trees, you have to consider those three cases: empty tree, one oak tree, and general tree. Then you will not miss anything. Okay or not? So this is the answer. But of course, if you are smart, you can simplify it. Yeah. Because once I've done this one, I'm very happy. To look at the book, the answer is different from mine. Yeah, it's shorter than mine. That means I am dumb. It's not. I'm not that smart. Yeah. So you may check it because it combines some cases. Yeah, into like that. Yeah. This one is okay. So it's fine. This one is fine. Sorry. Yeah, it's the next one. Okay. So this one we finish it. Question number 3. We finish it. We go to number 4. Any comment on that? Okay. Remember when you check it, 3 cases. Easier. Next one, what's that? The basic tree is recursive in nature, and then this one is not that important. Yeah. We proceed a tree by processing the root, and then it's subtree. Okay, based on this understanding and following the example of the height of the tree, devise the algo for calculating the height of the tree. What's the height of a tree? The last statement is important. That the other don't need to read. How do you define the height of a tree? So the height of a tree, you start from the root, you go to all the leaves. You see how many branches you have. The longest one is your answer. Example. Look at some example lah. This one. This one, if you look at it from the root 15, you go to 3, you have 2 branches. So this one is 3. Go to 7, 2. So from here, 2. So you look at 17, 19. 19 is 2 lah. First branch, second branch. Or actions, yeah. So depending how you look at it, how you read it. Okay, so now how about 17? 17, you go from here, 1 branch, 2 branches, and 3. So the height is the longest of them is 3. 3 is okay. How do we define it? You go from the root, go to all the leaves. You know the leaves, right? The longest one will be the answer. Okay or not? So with this in mind, we can find here. Okay. So how do we find the height of the tree? You look at it. So we have 3 cases, right? If the empty tree, what's the height of an empty tree? No tree. Can you put it 0? Cannot. So you have to define. So the computer scientists define as -1. Means no tree. You look at the number negative, right? Next one, 1 oak tree, right? 1 oak tree, what's the height of that? That one is 0. 1 oak, right? That one is 0. So if this is 1 oak tree, then you return 0. If this one is a general tree, what should you do? Recursive. Think about that. Then you don't know, but you pass to the next one. Tell me that what's your from you to the leaf, what's your height? Then you tell me that I add 1 to it, right? Because you are one of the child, yeah, one of the children, right? So this one very interesting, right? So you check the left sub-tree, what's the height? You check the right sub-tree, what's the height? And then at the end, you find the biggest one will be the answer. But your answer should be add 1 to it. Because from you yourself to the left sub-tree and right sub-tree, they are one branch, right? You add 1 to it. It's here. Okay. So you have to take care of 3 cases. Empty tree, one-note tree, general tree. For the general tree, you don't know your answer, but you ask your children. Yeah, what's your height? What's your height? Then each one report to you, right? This one is 2, this one is 3. 3 is the bigger one. Then from you to the child, 1 level, right? So will be 3 plus 1. So the answer is 4. At first, I don't know, but I asked the children, right? To know that, you look at it. So you ask the children, yeah, what's your height? You ask your right sub-tree, what's your height? They all report to you. You choose the biggest one, right? You choose the biggest one. Then you add 1 to it. This is a general principle. Then your children, what do? They will ask the grandchildren. They will ask the grandchildren, hey, what's your height? Yeah. Then they will tell you. Once they receive the information, they report to that generation. Eventually, will come to me, right? I know everything. So this is recursive. Think about that. Think about that. Yeah, because you don't know the answer. You say that time out. Yeah. You ask your child here. You ask another child. Another child say that, oh, I also don't know. Then you ask the grandchild. Yeah. Right? Grandchildren. This one also ask the grandchildren. Eventually you collect it and you find the bigger one of these 2. That will be the answer, but not exactly. Because from you to the child, there's 1 generation here, right? 1 generation. So you add 1 to it. So eventually you add 1 to it. Okay or not? This one is very systematic, right? Okay or not? This one very clear, right? So okay, so the left sub-tree and the right sub-tree. So you know that the 2 children will be taught, and each one you add 1 and choose the bigger one. Then that will be the height of the tree. Because the height of the tree is defined from the root to all the leaves. The longest one will be the height. What go to there means you pull the branches, the edges. Yeah. So you read as what, ages, yeah, something like that, right? Okay, not. Online students, any comment on that? So eventually you see that the systematic way is very helpful. Empty tree, one-note tree, and general tree. So you take care of them, will be very easy to find out. You don't miss anything. And you are confident that, okay or not? So this is my answer, right? My answer, I look at it, I check with the book. Seems that the book is easier. So I give you the book's answer. Yeah, I finish it and then I check the book's answer. The book's answer is very short here. So because it take care of something, yeah. This one, the more concise version is as follows. So they are shorter. They were they took care of two, empty tree and the general tree, and then but because of that, you look at it, the one look tree also work. This is a special case, yeah. Although I need to admit that they are smarter, right? But mine is also okay. If I use my code, I also get full marks, right? So this one is slightly more concise. They will take care of the one look tree. You look at it, because they add one to it. So only a very special case, the case is valid. For other problems, you need to go through three cases: empty tree, one look tree, and general tree. But for this one, they have some advantage. Yeah, they can miss one because you go through it, you find it. I don't go to the detail. Yeah, it works. It works. Because I use this question and then I check with the answer from the book. Yeah, actually, it's an example in the book. Yeah. Then I find that, yeah, how come they are shorter than mine, right? Then I look at it, they are right. Yeah, but doesn't mean that I'm wrong. But I'm not that concise. But I think they are very special. Yeah, for other problems, my approach may be easier. You don't miss anything. So I advise you to follow mine. Yeah, because not everyone is a genius. Yeah, you think that you are a genius, you follow this one. Okay or not? Yeah. So sometimes the algo is like that. When I mark your paper, sometimes I know the answer. Then I check it. It also works, and also your answer is better than mine. Yeah, you look at it, we have 700 something students. Maybe 1% is smarter than me. Then I will see about 10 very, very good answer. It's very often, yeah. Very often, yeah. So that's why it's a difficulty. I cannot just say that, yeah, your answer is different from mine, cause it not correct. Right? But if I read the detail, then I find that, yeah, maybe out of 700 something, yeah, maybe 5 or 6 students very, very good. Yeah, they can provide very very good answer. Yeah, neat answer. Yeah, so that's why it's the difficulty of marking. So when you write your algo, write your pseudocode, help me. Yeah, a poor guy will mark your paper. So write some comment on that. Otherwise, even you are very smart, I cannot tell you are smart, right? So you know that, yeah. So don't think that you are smart. You are not that smart, yeah. So like that. So put some comment or something like that. This one will also take care of one look tree. Say like that. Yeah, so I know that you know you are aware of that. Yeah, right. Then when I see it, I check it, then I know that I cannot just anyhow that cause you miss one case, right? So you have to protect yourself to get marks, right? Okay or not? Yeah. Because I'm not one student, I'm not marking one student's paper. I'm marking 700 students' paper. 778, very big. So this time I have I probably mark only half a question. Yeah, half a question is already 6 days. Yeah, so very, very detailed. Yeah. Okay, thank you. So any comment? So your trees, you know that is a lot of variety, much interesting. Yeah. Next. Next, what's that? We are given some functions, just like in C, you have some functions. So this function here return true, for empty tree. So it will ask you, is it empty? Yeah, something like that. So if empty is a Boolean, means true and false, true or false. The other one is return the parent of the node, of a node. The node is called V. So this one will be parent of V. So like that. This one is return is a Boolean, is root. If this one is a root, you are given three functions. Using these functions here, write an algo, means pseudocolon, to find the depth. The depth of a tree. The tree is called T. The node is called V. That compute the depth of a node V of the tree. So what's the depth? Previously you learned the height, right? The height is from the root, go to all the leaves. The one with the largest value is the height of the whole tree, right? Now this one is different. This one is a node. V is from this node to the root. This is called the depth of that. Okay, so height is the whole tree. So this one is different. This one is the depth. Depth is a node. From this node, you walk up to the root. How many levels? How many branches? How many edges? Okay. So can you use this well-defined functions and write an algo to compute the depth? Is okay? Example. Find one. Okay. Okay, so what is the height of 15? Not 15, 19. 19. What's the height of 19? So you walk up, there's only one path for trees, right? Binary trees. This is 1. This is another 1. So 1 plus 1 is 2. So the depth of 19 is 2. Next, what's the depth of 3? Every node you can define the depth. So you walk one step here, another step to the root. There are 2 steps. So the depth is 2. So if this one talking about 17, you walk here and then walk here and walk here. It's 3. The depth is 3. So that one is related to a node, associated with a node. The other one is associated, the height is associated with the whole tree, not a node. Okay or not?
So in this case, the height is 3.
The height of 17 is 3. So the height of 6, what's that? One level to the root. So it's 1. It's associated with each node. The other one is associated with the whole tree. So the definition, no big deal, you say. But once you understand it, you know what to do. So, so this is the last mile, right? Question number 5. Once you finish it, you can go home. So, how to do it? How do you know the height of this one? Use the same idea. You don't ask the child, you ask the parent, no? Right? So in Chinese or in some others, So you see that you are the 10th generation or the 5th generation, whatever, right? So how do you do it? So if you don't know your generation, how do you do it? Call your father. So what's your generation? So if you're 3 in the generation, if your father answer it, we are the 10th generation in Singapore, say like that. Then you already know that you are the 11th, right? Is it true? You call your parents, or you call so your father may not know, then he will call your grandfather. Then your grandfather said that, oh yeah, we are number 4. Then your father is number 5. You are number 6, right? You do it like that. So this is recursive. So your grandfather will call the grandfather. You keep doing that until you know the answer, right? So you use this idea, although it's a little bit interesting. So it's like that. Yeah. Let's look at the answer. So you know the answer, yeah, now. So the algo is T, V, right? Those 2 parameters. So if your tree is empty, so what should you do? -1, right? No tree. So also 3 cases. If the tree is empty, then there's no V, right? So it should be -1. If you have only a single node, and this one, the V must be the V, right? The root must be the V. So you return 0. You return 0 because the step from this V to the root in no steps, right? 0. Otherwise, what should you do? So you call your parents, right? You call your parents. You look at the tree, but you don't know the one here. You call your parents. Then you add 1 to it because between you and your father, you are 1 generation, right? You add 1 to it. Yeah, so you have to know that. If you don't know that, you go back and call your father and call your grandfather. Eventually, you will know that. One of them will tell you, then you know the answer, right? So this is, you look at it like that, it's fun, you say, yeah. So don't always treat this one as a very difficult problem. So actually, this one is the homework number 2. But the homework number 2, I look at it, it's about this idea, yeah. No, the solution is different, yeah. So even I cannot understand it because set by the examiner, yeah. I look at it a few levels, I cannot appreciate that, yeah. So I change it to the number 2 you have now. At first it's much similar to that, yeah. He has a few levels, yeah. So not that simple, that one.
You share the tutorial. I just want to check.
You want to check, you call your father lah. Then your father will call your father, yeah. So like that, then you also know that, yeah.
My father called you.
So I will give him this one, yeah. So give him. Okay, any questions? Yeah. So at first it's very difficult, yeah. So but I think that so probably you will not get the answer, yeah. So I change it to easier. Question number 2 you have, now it's easier, right? Actually it's not, Any questions? No, okay. So this is week 6, week 7, right? Week 7, as you know, the class will be split into 2. You are the first half, you come in and do it. And after that, the second class, the group B will come in and do it. So we have only 1.5 hours. The tutorial number 7, I will give you the link. So like that. How about that? Okay, any questions? Online students, any questions? Exam, trees and grass.
Share. That means
the depth means from that node walk up to the root. So how many levels? So you look at the one here.
1, 2, 3, then 3 level or 2 level.
You look at the branches you have. Yeah, look at it. For 17, you go up 1 level, 2 level, 3 level.
3 level.
For this one, 1 level, 2 levels.
It's the same as height lah.
Yeah.
It's the
But
same
but
as
but associate with each one of them. Okay, let me close this section first. Yeah, answer some questions. Yeah, locally. Thank you.
The bottom. Yeah.